Good day, grade 8. Welcome to the next lesson of maths. Today we're continuing on to a new chapter, common fractions. Now you guys should be familiar with common fractions because you have done them in previous years. So there's going to be a bit of repetition. So we're going to do a bit of revision, but then I'll also teach you some new things. Okay, keep in mind we call these common fractions to separate them from decimal fractions, which is the next section. So for this section, I always want the answer as a fraction, not as a decimal. So if your calculator gives it to you as a decimal, you need to make sure that you are putting it as a fraction. So you can't just use your calculator to give you as a decimal answer, you need to work it out as a fraction. Okay, now the first thing we need to know is that the top number on a common fraction is called a numerator. The bottom is a denominator. You should have learned that last year, okay, or previous years. Another thing to note is b, or the denominator, can never equal 0. Why? Because remember, fractions are the same as divide. So remember we said we can never divide by 0. We even tried it in class on a calculator and it gave us an error. So just like we can never divide by 0, we can never have a 0 at the bottom of the fraction. It is not allowed. It will give us a maths error. So our fraction should never have a 0 at the bottom, otherwise it will be error, impossible to do, does not exist. Okay, first thing we're going to look at is equivalent fractions. Basically, those are when fractions are like the same number. So for example, let's just say a over b. A and b can be any number. I'm just using as an example. And basically, if one number is multiplied or divided by another number, let's just say n, the bottom must be the same. So we have this rule in fractions: whatever you do to the top, you do to the bottom, or vice versa. Whatever you do to the bottom, you do to the top. So let's just take an example here, like 2/3. Okay, and we wanted to know what is an equivalent fraction of it. Well, if we multiply both the bottom and the top by 5, we get 10 over 15. But 10 over 15 is equivalent to 2/3. They are the same fraction, just written in different forms because they are both multiplied by 5. So if you multiply by the same number or divide by the same number, they are the same. Why do we use equivalent fraction? Well, sometimes we get a question like this: find the unknown number, where we have 2/5 equals question mark 20, and we want to know what is the question mark. Well, we think, how did we get from 5 to 20? What times 5 gives me 20? Think in your head, it's times 4. So then, because I did times 4 at the bottom, I must do it at the top. And what is 2 times 4? 8. Therefore, the missing question mark is 8. So this is 8 over 20. 2/5 is equal to 8 over 20. Okay, remember the question mark could also be at the bottom. Now keep in mind, if you are struggling to find out what the times was, like if you struggle to find this out, just think 20 divided by 5 will give you 4. So you can also use divide, because remember, divide is the inverse operation of times. So if you want to find out the times, you divide. If you want to find out the divide, you times. So you take the answer divided by 5 to get times 4. Okay. Then for example 3, replace star with greater than, less than, equal to. So we want to know which fraction is bigger or smaller. Now you can't just look at them and say by size, unless they have the same denominator. They must have the same denominator term. So we have to make the denominator the same. Okay, now there is a way to get a lower common denominator, but for now I'm just going to show you how to find any common denominator. And basically, you times each of the denominators by each other. So 5 times 6 and 6 times 5. Okay, so whatever the bottom ones are, I just times them. So if this was 4, then it'd be 6 times 4 and 4 times 6, just as an example. Okay, and remember, whatever I do, the bottom and the top. So since at the bottom I'm timesing by 6, at the top I must times by 6 as well. Since at the bottom I'm timesing by 5, at the bottom I times by 5 as well. 2 times 6 is 12, 5 times 6 is 30, 1 times 5 is 5, and 6 times 5 is 30. These are the equivalent fractions of the two. So 2/5 is the same as 12/30ths, and 1/6 is the same as 5/30. Now I can see which one's definitely bigger. It is definitely 12 over 30. Therefore, I can rewrite it in its original form, where I say 2/5 is greater than 1/6. So I must always write it in its original form to see which one is bigger. So 2/5 is actually greater than 1/6. Okay, you always have to get them to have the same denominator to find out. You do this by, again, I'll say it again, you times the denominators by each other. So 5 times 6, 6 times 5. And then whatever you do to the bottom, you do to the top. Okay, and that's how you can find out which is the biggest one. Similar to equivalent fractions, we look at simplifying fractions. This is where we find an equivalent fraction that is as small as possible. So we generally divide instead of times, but we always divide by the same number. For example, if they ask us to simplify 250 over 1,000, well, we can divide both of them by 250. We have to find something that can both be divided into without any remainders. Okay, 250 divided by 250 gives me 1, and 1,000 divided by 250 gives me 4. You can use your calculator to check this. Okay, I'm giving you permission for that much. Okay, so the simplest form is a quarter. Now when they say simplify, they want it in its simplest form. And how do I know 1/4 is its simplest form? Because I can't divide by anything else without getting remainders, and I don't want remainders. Okay, now keep in mind, you don't have to do this in one step. If this takes multiple steps, that's fine. Like in this one, instead I could have said 250 over 1,000 and then divided by 10 instead. 250 divided by 10, 1,000 divided by 10. 10 is common in both of them. I get 25 over 100. So this is an equivalent fraction. However, it is not its simplest form. So you cannot leave it here, because this can still be simplified further. So if you leave this as your answer, it is wrong and you lose a mark. However, I can simplify this further by then saying now divide by 25. So bottom by 25, top by 25, I get 1/4. Can you see I have the same answer? So what I'm saying here is you don't have to do this in one step. If you have to divide multiple times, if you have to simplify multiple times to get your final answer, that is fine. It's the most important is that you have this as your final answer. So if you do this way or the longer way, it's fine. You will get the same marks, doesn't matter. The only time you won't get the same marks is if you stop here. Then you will get 0 marks. It must be in its simplest form. Okay, it must be as simple as it could, meaning you can't divide anymore. This one, since we can still divide by 25 or even 5, we know it's not enough. Okay, so it doesn't matter if you take 2 steps or 3 steps or 10 steps to get the simplest answer. It's fine as long as you only stop at the simplest answer. You cannot stop before then. Okay, the next thing we are going to discuss, negative fractions. So basically, if one of the numerators or denominators has a negative, then the whole fraction is seen as negative. So for example, if I have minus a over b, it's the same as minus a over b. For example, minus 1 over 2 is the same as minus a half. Okay, if it's at the bottom, a over negative b is the same as a over b minus, so the whole thing minus. If both of them have a minus, however, that's like saying a minus divided by a minus. What's a negative divided by a negative? That's a positive. So it becomes a positive. Okay, for example, if we have minus 2 or negative 2 over negative 3, it is the same as 2 over 3. I don't have to write that plus there, I just wrote it to show you, but you can leave it out. That isn't necessary to be written. I just wanted to show it. Okay. If we have a fraction over 1, it is the same as if it was the whole number. So any number over 1 is the same number. For example, if I have 3 over 1, it is the same as 3. 5 over 1, 5. 2,000 over 1, 2,000. A million over 1 is a million. And keep in mind, this can work backwards as well. So if I have 5, I can transform it into 5 over 1. They are equivalent. They are the same fraction. So you can turn any whole number into a fraction by simply making it over 1, because it is the same one. So if you need to convert 20 into a fraction, just make it 20 over 1. It's the same thing. Okay, if we have a fraction over itself, it's the same as 1. So anything over itself equals 1. So 3 over 3 is the same as 1. 5 over 5 is the same as 100 over 100, or even 1. Okay, let's help them. So 3 over 3 equals 1. Again, I could even do this backwards. If I had to convert 1 into a fraction with a certain denominator, I could make 1 be 3 over 3. 1 also equals 5 over 5. 1 also equals 20 over 20. I can change it into any fraction I wanted to, as long as the numerator and the denominator is the same. Okay, same like this. I can make it 100 over 100 or 10 over 10. It's simply equivalent fractions. So you can change things as you need them to be changed. Okay, they are the same thing. Now for homework, I want you to do exercise 1, page 167. I want you to do all of A, 1, 2, 3, 4. You just have to tell me what A is. So use equivalent fractions there. It's the same as the one I did above with the question mark, except you are now doing it with A instead of a question mark. Okay. I want you to do B, where you simplify the following fractions. Remember, you must only stop at their simplest form. If you do not, it is incorrect. Okay, it is incorrect. And then leave out C and D for now. We'll come back to that. E, replace the star with greater than, less than, equal to. So it's very similar to what I did in the previous one. Okay, I want you to do 1, 2, 3, and 4. But remember, you have to make sure they have a common denominator first. So you have to do the method I showed you. If you just put greater than, less than, or equal to, I am not going to mark it. You are going to get 0. You are going to fail. So make sure you show your working out for E. You cannot just put greater than, less than. You can do it for the first one, number 1, because there it's obvious. But for E2, E3, E4, you have to show me the working out like I did in the example. Okay, even with B, I want to see what you are dividing by. I want to see your working out, please. Same with A. Show your working out like I did in the examples. Okay, and that is where we are going to stop for today. I will see you for the next lesson.